Welcome to my YouTube channel. Let me introduce myself. My name is Nyoman Nadyah Suyadnya Dewi. You can call me Nadyah. My number is 1913011027. I am from 3A Mathematics Education. This video will explain about mathematical logic. Subtopic this video: 1. Statement and its true value. Topic 2 is open sentence. 3. Subtopic is logical connectives, compound statement, and truth tables. The last is statement patterns and logical equivalence. Statement and its true value. Next is statement. A statement is a declarative sentence which is either true or false but not both simultaneously. Statements are denoted by the letters P, Q, and R. For example, 5 is a perfect score. Next, true value. A statement either true or false. The true value of a true statement is defined to be T, and then of a false statement is defined to be F. Next topic is open sentence. An open sentence is a sentence whose truth can vary according to some conditions, which are not standard in the sentence. Note: open sentence is not considered a statement in logic. Example: x times 5 equals 20. This is an open sentence as its truth depends on value of x. If x equals 4, it is true, and if x is not equals to 4, it is false. Next topic is logical connectives, compound segment, and truth tables. And or logical and conjunction. Conjunction is a table of compound segment that is comprised of two propositions, or also known as simple statement, joined by the AND operator. For example, V equals today is a pleasant day. Q equals I want to go for shopping. The conjunction of about two statements is V logical and Q. I ate today is a pleasant day and I want to go for shopping. A conjunction is true if and only if both P and Q are true. Conjunction truth table. V, Q, V logical and Q. True, true, then true, true, false, then false, false, true, then false, 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 then false. Or disjunction. A disjunction is a kind of compound statement that is composed of the simple statement formed by joining the statement with the OR operator. For example, 1. Rahul will pass or fail in the exam. 2. Candidates must be graduates or postgraduate. In e.g., 1 or indicates the only one of the two possibility exists, but not both, which is called exclusive sense of or. And e.g., 2 or indicates the first of second or both the possibilities may exist, which is called inclusive sense of or. Truth table of disjunction of P and Q is as shown below. P, Q, P or Q. True, true, then true. True, false, then true. False, true, then true. False, false, then false. Next topic is not or negation. The negation of a statement is also a statement with a true value that is exactly opposite that of the original statement. For example, P banana is a fruit, equivalent P banana is not a fruit. Truth table for negation is also below. P equivalent P. True, false, false, true. Note: if a statement is true, its negation is false and is false. Next material is if then implication conditional. For example, let P equals I travel by train, Q equals my journal will be cheaper. Here the conditional statement is P arrive to the right Q. If I travel by train, my journal will be cheaper. Conditional statement is false if and only if antecedent is true and consequent is false. Truth table for conditional is as shown below. PQ P arrow to the right Q. True, true, then true. True, false, then false. False, true, then true. False, false, then true. Note: equivalent forms of the conditional statement. Then topic is inverse and contrapositive statement. If V arrow to the right Q is given, that its converse is Q arrow to the right P. Inverse is negative V arrow to the right negative Q. Contrapositive is negative Q arrow to the right negative V. For example, let P equals Smita is intelligent. Q equals Smita will join medical. 1. Q arrow to the right P equals if Smita joins medical, then she is intelligent. 2. Negative V arrow to the right negative Q equals if Smita is not intelligent, then she will not join medical. 3. Negative Q arrow to the right negative V equals if Smita does not join medical, the she is not intelligent. PQ P arrow to the right Q negative V negative Q Q arrow to the right P negative Q arrow to the right negative V negative V arrow to the right negative Q. True, 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 false, false, true, true, true. True, false, 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 true, true, false, true. False, true, 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 false, false, true, false. False, false, true, 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 and true. If and only if double implications by conditional. For example, let P equals price increases. Q equals the man falls here. The by condition statement is V equivalent Q. Price increases if and only if the man falls. A biconditional statement is true if and only if both the implications have some true value. The table is P, Q. P equivalent Q. True, true, then true. True, false, then false. False, true, then false. False, false, then true. Then statement patterns and logical equivalence. Statement patterns. Let P, Q are the simple statement. A compound statement obtained from this simple statement and by using one or more connectives. And, or, negative, arrow to the right, and equivalent is called a statement pattern. Following points must be noted while referring through tables of the statement patterns. 1. Parentheses must be introduced whenever necessary. For example, negative quantity P and Q plus quantity and negative V and Q are not the same. Next, logical equivalence. Two logical statements are said to be equivalent if and only if the true value in their respective columns in the joint true table are identical. If S1 and S2 are logically equivalent statement patterns, we write S1 minus S2. As for the logical equivalence operational properties, 1. Negative quantity P or Q close quantity identical to negative V and negative Q. De Morgan's law. 2. Negative quantity P and Q close quantity identical to negative V or negative Q. De Morgan's law. 3. P arrow to the right, Q identical to quantity negative V plus quantity or Q. 4. P arrow to the right, Q identical to quantity P arrow to the right, Q plus quantity and quantity Q arrow to the right, P plus quantity. Next topic is tautology, contradiction, and contingency. 1. Tautology. A statement pattern having true value always T, irrespective of the true values of its components. Statement is called tautology. 2. Contradiction. A statement pattern having true value always have, irrespective of the true value of its component. Statement is called a contradiction. 3. Contingency. A statement pattern which is neither a tautology nor a contradiction is called contingency. Question 1. Prepare the true tables for the following: 1. Negative V and Q. 2. V arrow to the right, quantity V or Q close quantity. 3. Negative V equivalent Q. Solution: 1. Negative V and Q. In tables, VQ negative P, negative V and Q. True, true, false and false. True, false, false and false. False, true, true, true. False, false, true, false. Solution 2. V arrow to the right, quantity P or Q plus quantity. P, Q, P or Q. True, true, true. True, false, true. False, true, true. False, false. And P arrow to the right, quantity P or Q plus quantity is true, 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 false, true. Solution 3. Negative V quantity, negative P equivalent Q. P, Q, negative V. True, true, false. True, false, false. False, true, true. False, true. Negative V equivalent Q is false, 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 true, 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 false. Thank you for watching and goodbye.